As I might have mentioned to you the last 10 hours, we're going back to testing again, and I want to look at the area of end-to-end testing or system testing. So you'll find the slides that I'm going to walk through here. So end-to-end testing, or E2E, is a slightly more modern term that we use. Traditionally, we would have called it system testing. And so we're testing the entire application as a unit or as a whole, if you like. And so by the entire application, we're talking about, well, presumably the application has a user interface. It may not, though. Some applications may actually be completely server-side. They may not have a UI at all, but in our case, they do anyway. So there's a UI involved, a user interface. There's some sort of server-side involved. And there may even be a database involved as well. But the entire thing is the system, or from end to end, if you like. And so when we're doing system testing, the kind of issues we're concerned with is, obviously we're concerned with, is the functionality working okay? That is the functionality from the UI perspective now, from the user's perspective. And if it's a web-based application, then, you know, it's, if the user clicks on something, does the application respond in terms of the UI change in the correct way? In general, when you're doing system testing, you're also concerned with performance testing and load or stress testing. We're not going to look at those two areas. We're just going to concentrate on functionality, but clearly performance would be an issue if it's a web-based application, for example. Does the UI respond in a timely way? Is the latency low or high? Load and stress testing might be, if it's a web-based application, how does the application perform under large user interaction scenarios? So there, it's kind of felt that when you're doing system testing, you should either concentrate on one of those three areas in terms of designing your testing. So you might have one set of test suites that are just concerned with functional testing. You might have a completely separate set of test suites when you're doing performance testing, and yet another set of test suites when you're doing load or stress testing. You keep them very separate. Anyway, we're only concerned with the first one there. We often use this term black box approach when we're doing system testing or end-to-end testing. A black box, the kind of analogy is, a black box is a box where you can't really see the internals of the box, and you're kind of not concerned with the internal workings of the box. All you're interested in is, if I provide certain inputs to the black box, then does it give me the right outputs or the expected outputs as a result? Now, in terms of testing web-based application, that means, you know, if the user interacts in a certain way with the browser, does the UI in the browser change accordingly? We're not really, when we're doing end-to-end testing, we're not concerned with the internals of the functionality, of the internals of the code base, I suppose, really. If you've done your testing properly, then you would have done a lot of unit testing prior to doing end-to-end testing. And in unit testing, you are concerned with the internal workings of your code, and you are trying to iron out a lot of the low-level bugs that might be in your code. But when you're doing end-to-end testing, you're really just testing the system as if it's a black box. You're only concerned with inputs and outputs from the black box. You shouldn't be finding low-level errors when you're doing end-to-end testing if you've done your unit testing properly. Of course, in real life, you will come across them, but you should have ironed out a lot of the low-level errors in your code base from your unit testing. So that's this kind of just black box. It's just a term that's used that you may come across. I'm saying there as well here that you may also be interested in, when you're doing end-to-end testing, you may be interested in certain side effects that your tests may cause. In particular, for example, if your application, if a particular user interaction is meant to cause some changes to the actual backend database, then you may actually build that kind of testing into your end-to-end testing scripts. We don't do it in the labs, but it's just a concern that you may have. The third point there, the asynchronous nature. Well, certainly if we're testing web apps, or even if you're testing a mobile app, then by definition, the entire application is distributed, as in part of the application is running in the front end. Another part of the application or the system is running on the server side. And the server side may even be communicating with other third-party web services. So there is a network connection involved. And so the whole application is asynchronous in nature. Now, ideally, whatever tools you're using to do your end-to-end testing, it takes care of dealing with that whole asynchronous aspect. You don't have to worry about it in your code base, and you'll see that that is going to be the case in the coding that we will be doing. But sometimes you may hit on error, or some tests may fail, and really the reason they're failing is because the network connection that you have is just slow. Hopefully the testing framework will accommodate that. You don't have to actually build delays into your testing code, but you just need to be aware of it from a general point of view. So from here in I'm just going to talk about, I'm going to use E2E testing because that's really because we are going to be doing system testing in the context of web apps because of the web app dev 2 module that's running in parallel. And when you're doing system testing for web apps, then the term end-to-end testing is always used. So the web app is the target of our testing, and by implication, then the browser is actually part of what we'll be testing. When we are writing our tests, we're really writing our tests against the browser interface of the particular web application that we're dealing with, which in our case will be the Movies app. And again, as I said, we're only going to be concerned with the functionality of the web app. We're going to be concerned with form submissions. If there are web forms as part of our app, we want to make sure that they work properly. So that, for example, would mean in real life, when you submit data on a form, more than likely that data is going to finish up in a database. And so you would have to check that it did actually finish up in the database. Again, we can't do that right now because we don't have a backend to our Movies app. You're going to be interested in navigation, obviously, that's all working properly. If there are flows in your web app, which there won't be in our case, you will be testing those. Now, the last one there on that list, visual testing, is really about the whole CSS side of your app. We won't be addressing visual testing, but clearly it would be a very important part of web app testing. There are separate tools for doing visual testing. And especially if you've got a lot of custom CSS as part of your web app, then visual testing is going to be very important. Because if you have, let's say, you've defined a CSS class in your CSS code, and somebody comes along and makes a change to that CSS class, that's obviously going to impact on the visual side of your UI. It won't impact on the functionality, but it will impact on the visual side. And ideally, you would like your tests to show up the fact that something has changed in the UI. But that's just there as a side issue. When it comes to automating end-to-end testing, web apps have been around for a long while, and automation tools for testing have been around for a long while. Now, for a number of years, if not decades, the tool suite that people used for web app testing, end-to-end testing, was a combination of Mocha, which we know about, Chai, which we know about, and the third part of the suite is something called Selenium. So Selenium is very popular out in industry, mainly because it was probably the first end-to-end testing framework on the market. And so it's been around for a very long while. A more modern automated end-to-end testing framework is one called Cypress. And that's the one that I am actually going to focus on. I have used Selenium as well, but I think the feeling is that Cypress, because it was actually built from the ground up, and it addresses more modern aspects of web apps, that it's probably a better approach than Selenium. But as I said, Selenium is very commonly used out in industry. And so this Cypress testing framework, it uses Mocha and Chai internally. So all of that Mocha stuff and Chai stuff that we already know about, in particular Mocha, as in describe blocks, it blocks, before hooks, etc., etc. All of that coding style reappears now when we start doing end-to-end testing using the Cypress framework. Cypress is open source, runs on all platforms, etc., etc. So it's essentially, we install it as an NPM module. The last point there on the slide is that Cypress doesn't deal with visual testing. It's really only concerned with functional testing for end-to-end web apps. There is another framework called Percy, which is probably the leading visual testing tool for end-to-end web app testing. So you install Cypress as an NPM package, which is nice. Now it does actually, as well as installing the Cypress framework, that particular command there also installs a binary executable, which is fairly hefty. So it's actually a fairly significant download that's happening there behind the scenes. So you need to make sure that you're on a good network connection when you are actually running it, which you will be in the labs. And when you run the Cypress framework for the first time on your web app project, then it creates a default folder structure, which you should utilize. And this is what the folder structure looks like. So it creates a Cypress subfolder within your project. And inside there are a number of subfolders within the Cypress folder. The one that we'll be really interested in is the integration folder. That's where we will be putting our testing code. The fixtures folder is where you would put test data. I don't think we do it in the labs, but it's there anyway. The plugins folder is fairly obvious because there are a number of plugins that have been developed by the community over the years for Cypress. And the support is kind of linked to the plugins as well. Or in the support folder, you could actually put your own extensions to the Cypress framework. The last thing there, the cypress.json, that is Cypress's configuration file, and we will have to put 1 or 2 entries into that configuration file. So what it means then in the context of the movies app folder, for example, is we will be writing Cypress test scripts, and we will be putting them into the integration subfolder of the Cypress folder. By default and necessity, really, the files have a .spec.js extension. Spec is kind of short for specification. So you can see there, it looks like I've written some Cypress tests for the home page of my Movies app and also for the Movies detail page. Cypress also has its own command line tool. In fact, it has a tool, but that tool has two different modes of execution. And this is really what you will be using to run your tests. Now, when you're running your tests kind of locally on your machine, then you would use the npx cypress open command. And as we'll see in a while, that actually starts up Cypress's own graphical user interface tool. And it's quite easy and nice to work with. The second one there, npx cypress run, you would use that command if you just want to run all of your tests in one go. The first one, npx cypress open, is what you tend to use as you are developing your tests. The second one is when you just want to run the whole lot. Also, the second one is the command that you would use if you want to run your tests in a remote server. And in particular, when eventually we will talk about something called CI/CD, continuous integration, continuous deployment. It's kind of the next topic, actually, maybe next week or afterwards. And we will be running our Cypress tests on remote servers. Now, those servers actually won't have a UI side to them. They won't have a browser running. So we often refer to running tests in remote servers as running our tests in headless mode. Headless as in there is no actual user, there's no actual screen, if you like. So we write our Cypress test code, if you like. And a very simple example of what a Cypress test script might look like. Let's supposing we have our standard little to-do web app. And we've all seen these to-do apps. So the idea is, if you haven't seen them before, let's suppose this is a text box, and when I type something into the text box and hit return, my to-do gets added to my list of to-dos here. So you type something, hit enter, type something else, hit enter, and this little list here builds up. Okay, so supposing I want to test my to-do app to see does it work properly. This might be a simple Cypress test to do that. So straight away you can see I have describe blocks and it blocks. So that's the Mocha influence, and I don't have to explain that to you. So all that's new is this code here, and this is the Cypress code. All Cypress statements begin with CY, which is an object that's exported by the Cypress framework. Now, you could kind of work out what's being done here. The thing is that these tests actually run in the browser. The assumption now is that I have started up my to-do app. Maybe this is a React app, and I ran npm start. So my server, my React development server is running. And so when I run my Cypress test, what Cypress will do is it will open up a browser tab. It will send this code down to the browser plus its own Cypress framework code, and it will execute this line by line. So the effect of this statement being executed is the browser tab that it has opened is going to enter this into the browser's URL. And of course, more than likely, what should happen anyway is my UI will appear in the browser tab. Here, what I'm actually doing is I am getting the input DOM element, which is clearly this one. I'm accessing the input DOM element because, as I said, this code runs in the browser. So what is actually happening, a lot of the code that you write, the Cypress code that you write, is concerned with accessing the DOM and interacting with the DOM. In other words, the Cypress code is really simulating what a user would do if they were manually testing the app. So anyway, this statement has the effect of accessing the text box in the DOM, and I'm actually typing something into the text box. So I'm typing my to-do. This bit at the end actually is how we simulate the hitting of the return key in Cypress. And then I'm typing something else into the text box and hitting return again. So what I'm simulating is entering 2 to-dos into my list. The next thing I'm doing in my test essentially is I'm checking to see, does my list contain 2 entries in it, which it should. So we're assuming now that maybe when this app loads into the browser initially, there are no to-dos being displayed. That's a reasonable enough assumption. What am I doing here? Well, you'd have to see the actual HTML that's generated here, but you could presumably work out that it must be the HTML that's generating this list is either an ordered list or an unordered list from a HTML point of view. So these are all LI elements in that list. And so what I'm doing here is I'm getting all of the LI elements that are currently being displayed on the screen are contained within DOM. And I'm checking is the length, this expression here is actually going to return an array of LI elements. And it looks like what I'm doing here is checking that the length of that array is equal to 2. Yeah. So for now anyway, a Cypress test is a whole series of these commands, all beginning with cy.something. Most of the commands are concerned with accessing some part of the DOM, which I'm doing here and here. Some of them are concerned with interacting with the DOM, which I'm doing here. Some of them are concerned with making assertions about what you found on the DOM, which I'm doing here. So that's our first look at what a Cypress test code looks like. So arguably it is a declarative style of coding. And there's a lot of meta chaining going on. That's programming style. You can see here, this is an object and I'm invoking that method of the object. Whatever that expression returns, which is something we called a subject, it returns, I'm invoking the should method on that subject. Up here, same kind of idea. This expression returns what's called a subject, which is really a reference to some part of the DOM. And I'm invoking another method on that subject. The type returns the subject as well, and I'm invoking that on the same subject. So it's this kind of meta chaining style. So all of these statements that you write in a Cypress test follow this pattern. There's a command part and an assertion part. So we refer to this as the command part and followed by the assertion part. Sometimes there won't be an assertion part, there'll only be a command, and you saw that on the previous slide. Now, in terms of the commands, there's a whole set of them, and you kind of build up your knowledge over time, really. Here are some of the commonly used ones and what you see in the lab. All of the commands, as I've already said, all of the commands are about accessing a certain part of the DOM within the browser, because our tests run in the browser, so they have access to the DOM. So here are some of the examples. The get command is when you want to get a particular element or set of elements in the DOM, because we saw on the previous slide, when I tried to get the input DOM element, there was only one instance of it, so it returned one DOM element. Whereas when I tried to get the LI element, there were actually a number of those. So in that case, the get returned an array of DOM elements. So it could be an array or a single instance. but either way, it's getting some part of the DOM. Contains is if the DOM element you're looking for contains a piece of text that you know about that's displayed on the screen, then the contains is another way of accessing a particular DOM element. So for example here, I'm looking for the DOM element that contains the text welcome. The find is what you use if you want to chain on something after a get. So I suppose if we look at the example here, the way you interpret this is I'm looking for the element in the DOM of type form, and I'm assuming in this case that there is only one element of type form, i.e. web form. And then, but that DOM element will have a number of child elements within it. What the find does is it is looking for a particular child element or elements within this one. And it looks like here I'm looking for the select element within the form, which is a kind of a drop-down menu. And just to make it a complete command, this is actually how you would select one of the options in the drop-down menu. So from here to here, I'm looking for a particular DOM element. This part here is actually interacting with that element. Sometimes we have interaction, sometimes we don't. So anyway, that's the find. Another example is, well, if you want to click on a DOM element, then there is a command called click. So that's fairly straightforward enough. I'm here and getting the button. I'm assuming there is only one button. If there was more than one, then this wouldn't work, which would be something you'd have to debug. And I'm clicking on the button. The equals is very useful as well. And again, an example might be the best way of explaining when you would use equals. So the scenario is I've got a table on my page and I'm looking for a particular column of a particular row. So here's my statement here. First of all, oh, sorry, no. No, sorry, this is a slightly different example. Let's run with it anyway. Let's assuming I've got a number of text boxes on a particular web page. So the cy.get input is going to return the array of all of the DOM elements of type input. This here is going to pick out the third one in that array because it starts at index 0. So 2 is the third one. So I'm picking the third text box and it looks like I'm typing something into the text box. Here's the table example that I began to talk about. So I'm getting, have I made another mistake? I have. I keep talking about table and there's no table there. It must be later on in the slides. Hopefully, maybe you can work out this one now. Here I'm looking for all LI elements. I'm picking out the third one and I'm making an assertion that the third one should contain that string. That looks like it's from my to-do app kind of context. So the equals can be very useful when a get returns an array of matches, but you're only interested in one particular entry in that array for the purpose of interaction with it or for the purpose of making an assertion as I'm doing here. So they're just some of the commands, but if you go to the Cypress online documentation, then you'll find there are quite a number of them. I haven't counted them, but you're talking about maybe 20, 30 plus. And a lot of them, it's only maybe a subset that you will actually find yourself using, but that's okay. And I've tried to use a good range of them in the lab exercise so that you get build up a kind of knowledge of the kind of commands that are available to you. Certainly in the case of the get command and the find command, you use what's called a selector. And the selector is how you express what you are looking for in the DOM. Now, the selector is kind of based on the CSS jQuery selectors that we use. So we're kind of familiar with those. So for example, the selector might be where the particular DOM element that you have has an ID attribute. And so what you do is you prefix the selector with the hash symbol. So this I'm looking for a particular DOM element with that ID. Obviously, if it's an ID, then it's only going to return one match. If you want to pick out a DOM element based on a CSS class that it has, then this is how you express it. The dot here is significant. So this is telling Cypress that you're looking for a DOM element or elements that have that particular CSS class, and it'll return back whatever it finds. If you just want to pick out the DOM element or elements based on the HTML tag type, then you just express it like that. You put the actual HTML tag name within your quotes. If it's you're selecting a DOM element based on a tag, but also that DOM element has some other attribute. So here, for example, I'm saying I'm looking for the button, and in particular, it's the button that has the type attribute associated with it, where type is equal to the value submit. I don't know if you're aware or not in terms of HTML, in many cases, the browser doesn't really concern itself with attributes associated with DOM elements. And so if you have a DOM attribute that you make up yourself, then the browser just ignores it. But there does happen to be one or two HTML attributes that have been introduced specifically for the whole area of browser-based testing. So data test is actually a valid DOM or HTML attribute, and you can assign it any value you want to. And so that might be something that people can use, or that we can use when we're writing these kind of expressions here. Because no other certainly at runtime, the data test attribute really doesn't have any impact on a web app at runtime. That's just by the way. I'm not sure. I don't think I actually have a cause to use it in the labs, but the ent child attribute, that's what I was banging on about there in the previous one. So that's again, this is where we're trying to pick out a particular column of a particular row in a table. So it's an actual it's just a value in this case. We only tend to use that ent child attribute with the equals command. So it's slightly out of sync with all of the other ones. And you can combine these as I'm doing here, for example. This looks like it's looking for the DOM element or elements of type div that have that CSS class. So that's selectors. So we have commands, we have selectors. What's next? Well, sorry, if I go back, I'm not talking about the assertions part or the expectations part, because we have a sense of that when we talked about unit testing. Now, admittedly, the syntax for expressing expectations or assertions are slightly different, but again, I've given you lots of examples in the lab exercise. So hopefully you'll have enough to suffice to get through the lab exercise and indeed for the assignment. And we know what the notion of assertions or expectations are from our unit testing discussion. So I'm not covering that side of Cypress because it's really a Mocha and Chai thing. In terms of running our Cypress tests, as I've already mentioned, our Cypress tests actually run inside the browser. And so you have full access to all of the browser's resources if that is important for a particular web application that you're testing. For example, if your web application is using cookies, Presumably as part of your test, you want to check, well, did my browser receive a particular cookie from a web API? And you can write that kind of code in your Cypress scripting. The other thing I'm saying here is that Cypress is completely, I'm saying it's framework agnostic. It doesn't know anything about React or Angular or any of those other single page app frameworks. Cypress works completely with the DOM. And of course, the DOM is native to the browser. And that's what's really nice about it, actually. Notionally, anyway, we're saying that Cypress is flake free. You see, because your tests are running in the browser, and the browser is inherently an asynchronous execution environment, then that introduces a lot of kind of uncertainty or lack of deterministic characteristics. And so Cypress tries to make your tests as deterministic and repeatable and consistent as possible, so that every time you run your tests, you get the exact same result. That wasn't always the case with Selenium, for example, which was the precursor to Cypress. So we'll see a little bit later on how it tries to minimize the unpredictability and non-repeatability of your testing execution. For example, I'm saying here, like when a particular command runs, so if a command is looking for a particular DOM element and it doesn't find it, what Cypress actually does is it reruns that command a certain number of times, because the DOM is something that's built in the browser at runtime. And so for a slow browser, it may build the DOM quite slowly. So the Cypress test kind of has to wait for the DOM to be completed. And so that kind of waiting is built into the Cypress tests at runtime without you having to explicitly code it in your Cypress scripts. I'll explain what I mean by time travel there a little bit later. So this is all a lot of talk now, but if I just demo something. So here's my Movies app, and I've written some tests here. So I've written a test for the home page, the Movies detailed page, and I've written some navigation tests as well. So how do I run Cypress? First of all, you've got to start up your application. Then in a separate terminal, you have got to run the Cypress runner. And so the command is npx. So this is going to start up the Cypress graphical user interface tool. It's not running any tests yet, though. So this is the Cypress GUI. And what it does is it lists all of the test scripts that it has found in your project. And this corresponds with the ones that I showed you. Okay, these three here. And so these are clickable, and if you click on them, what will happen is Cypress will open up a completely new browser instance. It'll open up a tab in that browser, and it will run the tests. It will send the test code down to the browser, as well as some of its own Cypress framework code, and then it will run the test in the browser. So if I click this one, you'll see what happens. So it's running through my tests, and you can see what's happening in the browser as it's running through it. If I run it again, if I can, am I allowed? I think this reruns the test. And what you see here on the left is a kind of an audit trail of essentially kind of each command in your test script. And we can expand on these. So these are the individual commands. You can see there's some gets there and find, etc., etc. So you have an audit trail of each of the commands that were executed. And here you have the visual side of what was happening. And this entire audit trail is kind of clickable. So you can go back to an earlier stage in the test. And you can see here, as I'm mousing over the different commands in the test, you can see on the right what the state of the browser's UI was at that particular time in the test execution sequence. And that can be, this is what I mean by this time travel idea. And that can be very useful when you're kind of trying to debug, why isn't my test doing what I expected it to do at a particular time in the sequence of commands in my test suite, test script, sorry. So that's what I'm just illustrating on that slide there. So that's how you start up the Cypress GUI, or its interactive CLI, if you like, whatever you want to call it. The time travel, I've kind of given you an indication of that, right? So you can actually, and you can freeze it at any time. Notice here as well, right? I've actually 2 browser instances running. So one of the, I think, sorry, not that one. That was the browser instance that I opened up myself, you know, which has my stuff in it. The second browser instance is what the Cypress GUI kicked off. Okay, so there, and it opens up its own browser instance and runs the tests inside that browser instance. It doesn't open up a tab in the existing browser instance that you're running, so it keeps that kind of nice and separate. What I was saying there is, in terms of the time travel, you know, as I move back and forth, you can see, but if you click on, it essentially freezes the UI at that particular point, and then you can examine, well, it looks like here, what was I doing in the test? I think this is the test where I'm testing the filtering, and can we work it out? Oh yeah, if I go back a little bit further, what I'm actually doing here, obviously I have to show you the code, but what I'm doing here is simulating typing the letter P into the filtering of the movies, of the list of movies. So if I freeze it before I type the P, as in here, maybe that's a bit too early. I'll do it here. So I have my, sorry, went forward in me. Freeze it there. And you can see I have 20 movies, which is what I'd expect. But after I type the P and hit enter, which would be here, I can now see there's the P, and it looks like there are only 4 matches, and here are the 4 matches. So that all kind of adds up. Now you'd only be doing this as you're kind of debugging your test and debugging your application. That's the time travel idea. Test brittleness. Well, the only key point here, I suppose, is it's probably not a great idea to overuse CSS selectors as your selectors, especially if you've got a lot of custom CSS in your web application. Now we are using, in the Movies app, we're using Bootstrap, which is a third-party library. So that's probably okay. But if you're writing a lot of your own custom CSS, which is probably going to be subject to change, then using CSS selectors might make your testing code quite brittle, because if somebody decides to change a name of a CSS, custom CSS class, and you're using that CSS class within your test scripts, then that now means that your test is going to fail simply because somebody renamed a CSS test class to be something for whatever reason they renamed it. So that can impact on the brittleness of your tests. Okay, I'm just going to move on from there. Now, it's very, in terms of writing your tests, what you will find very useful is the Chrome developer tools, because what the Chrome developer tools, and I've illustrated this to you before, is it shows you the actual HTML and consequently the kind of DOM that exists in the browser for your UI. So what I mean by that is, if I go into here, and I've just actually, this is my own browser instance now, and I've actually loaded up the app in the browser. I don't have to have that done for the tests to run, but just to illustrate this to you, what I'm talking about here. We know if we open up the developer tools, and supposing I want to write a command in my test script that, let's say, it picks out that particular value there, right? Now, and I want to know what is the DOM element that generated that little value there. Well, what I can do is use the developer tools. So click on this icon here, then mouse over the particular element that you're interested in, which in my case, if it lets me, is that, and click it. And here on the right, it's showing me the exact place in the HTML that generates that. So it looks like it's a span. It's a span, and again, you probably work out, you probably need to determine what is the span's kind of parent element, which looks like it might be a paragraph. So all of that kind of information is going to be very useful to me when I'm actually writing my Cypress command to pick out that particular DOM element. So that's going to be your best friend, really, as you're writing your own Cypress test code, this developer tools. So that's what I'm illustrating there. And so the steps are: click on this first, then mouse over the particular part of the UI that you're interested in, click on that, and the developer tools will bring you to that particular place in the raw HTML, and consequently the raw DOM that's behind the UI. And then you use that information to write your Cypress command. The headless test runner, well, when you type in this command, the command that I ran was npx cypress open, and that opened up my Cypress GUI tool. But if you type this command, what it actually does is it runs all of your tests. It doesn't kick off a browser instance or any of that. It runs all of your tests. And it actually generates a video recording of the execution of those tests. I quickly do it, even though it's probably going to be a little bit on the slow side. Stop that, kill it as well. If I now go npx cypress run, and this looks more like the response that I get here now looks more like what we would have got when we were using Mocha in unit testing. So it's running through all of the tests. So internally, it is actually starting up a browser instance, but it doesn't appear in your screen. So it doesn't have a UI side to it, if you like, which is why we call it a headless execution mode. Now, what it has also actually done is, if I look inside my Cypress folder, you can see here, there's a videos folder. And inside there, there is an actual MP4 video file has been created. And I won't do it now, but if you clicked on those outside in the in your Windows Explorer or whatever, it will actually run the video and it'll show you essentially it'll show you what we saw when we ran the tests in interactive mode. Now, clearly, these videos should not be stored in your Git repo, which is why in my Git ignore file, I have told it to ignore the video folder within the Cypress subfolder. But it does generate those. And what's nice about these is we can share these with other people, other members of the team, if you like. So that's this headless test runner. Cypress comes with its own dashboard, which is a kind of a website supporting the Cypress tool itself. And I'm showing you here a screenshot. So what you will do is actually go to cypress.io, that URL there, create an account for yourself. And then in the lab, I explained to you how you set up your Cypress tests so that if you run your Cypress test locally in headless mode, which I did there a moment ago, what Cypress will actually do is it will send the video recordings plus some other metrics on the outcome of the tests. It will send them up to your dashboard account on cypress.io. And that's what I'm showing you a screenshot from here. And so the benefit of that now is that other members of the team can access the dashboard for a particular project to see what the outcomes of the tests were. So it facilitates information sharing, I suppose, or collaboration in a project, in a team project environment. What actually happens behind the scenes when you run a Cypress test is Cypress kind of pre-processes the test script and it builds a queue of commands. So when it actually analyzes, if we take that test script there on the left, it will actually analyze the test script and it builds a queue of the commands. It constructs that first of all. And having constructed that, it then goes back to the queue, beginning of the queue, and it executes the commands one by one. And as I've kind of already alluded to, if any particular command fails, then it actually retries it. Now, there's a limit to how many retries it carries out. You can configure that though. I think the default is 3, but I'm not certain about that. Now, obviously, if after 3 retries, the command still fails as it hasn't found the particular DOM element, then the test fails at that stage, and then you go do your debugging. Okay, but it's this idea of it builds a queue representation of your test script and then goes back to the beginning of the queue and runs the commands one by one. And that kind of facilitates this kind of deterministic nature of Cypress. It's not, what it does not do is run these commands as it finds them. Okay, it kind of builds a picture, first of all, of the entire script in the form of this queue, and then runs the commands, runs the entries in the queue one by one. So this is a kind of an English kind of documentation of exactly the sequence that the Cypress runtime goes through. So, and this is with reference to the previous slide now. So for example, it tries to find a particular element based on the get command that we had in our script there on the previous screen. And it'll retry it a number of times until it finds it. This is to accommodate the fact that the browser may be quite slow in building the DOM. Now, eventually it'll time out if it doesn't actually find it at all, as I was mentioning there a while ago. And it repeats that kind of for each of the commands that it has put into the queue that it has constructed for itself. We use a lot of command chaining, as I've already mentioned. Each command in the language of Cypress, each command returns what we call a subject, which is just a type of object that Cypress kind of constructs. We don't have to worry about the structure of that object. So this is a command, then we chain on this command, and then we chain on this command. Each command returns the exact same type of object, which we just refer to as a subject. And so the subsequent command is being invoked on that subject. Just to explain this one here, I'm getting the H4 element. I am actually assuming in this case that there is only one H4 element. What next is, this is a new command we haven't seen. Next picks out the next DOM sibling of the H4 that it has just found. And then I'm just checking, it looks like I'm checking to see, does that next DOM element contain this text? So this must be from the Movies app. Same kind of stuff here. Chains always begin with the CY object, which is the kind of global Cypress object, if you like. Each command uses a subject. Yeah, that's okay. Slowly running out of time. Sometimes you actually do want to take the subject and program against that subject object, if you like. And if you want to do that, and there are one or two small cases where we do it in the lab, then you use the then command to do that. So you can see what I'm doing here. I'm picking out a div, picking out all divs actually. In particular, I'm picking out the third div in the DOM. Within that div, I'm looking for a button. And now I want to interact programmatically with the button DOM element. And so if I want to do that, then I've got to chain on the then command. The then command, or the then method really, takes a callback, and the callback looks like this, right? The callback function takes one argument. So this now at runtime is going to be bound to the DOM element that was found up here, and I can do whatever I want to with it. There's a little bit too much going on in this slide for me to try and rush through it, so I'm not going to do that. And it's only by way of background information. I think that is the last slide. In terms of labs, so naturally there is a lab associated with this section, which is here, and I haven't revealed it to you yet. The lab is dependent on you having completed part 2 of the Movies app for Web App Development 2. So you must have that completed before you can even start this lab. The last part of this lab, which is this section here, it is actually dependent on part 3 of the Movies app being completed, and you're only starting part 3 kind of from yesterday onwards, or maybe next week, really, in reality. Now, what I say at the beginning of this lab is what you will be doing is you will actually be writing your testing code in the same project folder that you are using for Web App Development 2. Okay, don't make a copy of it because that only makes things a little bit messy for yourselves. So you will be using the exact same Movies app folder that you're working on for Web App Development 2. What that now means is that you will be committing to the repository as a result of work that you're doing on the Web App Development 2 labs and this lab, this Cypress lab. So there's going to be a mixture of commits. Now that's okay, because so what you will be submitting to me is the movies app folder minus the node modules. And that is going to have Git commits from this lab, the Cypress lab, and the Web App Dev 2 labs. And that's okay, they will be mixed. What is really important though is that the sequence of commits relating to the Cypress testing has to follow exactly the sequence that they are prescribed here, which we know about that kind of rule now. There are a couple of exercises in this lab. So my prediction is this lab is going to take you longer to do than any of the other labs that you've done so far, which is why I've extended the deadline to Friday evening rather than Thursday. You cannot begin this Cypress lab unless you have completed part 2 of the movies app, which you should have completed from the end of last week. So I will reveal this, but my advice to you is I would actually continue working on the web app labs and work as far into part 3 of the web app labs before you start this. So you may not find yourself starting this lab until maybe Monday, Tuesday of next week. That would be my advice to you.